Hello, welcome to project management course. In this video, I'll be talking about project schedule management. So looking at the other ones we've done, going through the scope management, we talked about a few things, and then we spoke about the decomposition of the WBS, where we said that the last package and the last part of scope management that comes from the decomposition of the WBS is work package. Any further decomposition after the work package gives us activity list. And once we start talking about activity list, we are already little by little getting into schedule management, because activity list is the first and the easiest thing to work with under the schedule management. But let's quickly look at the processes under the schedule management. We have the schedule projects, we have the define activity, sequence activity, estimate activity and resources, estimate activity duration, develop schedule, and then we have control schedule. So under define activity, what are the things we do? And as you can see, the key output here is activity list. The things we do is to put all of those activity and define them into exactly what they are. So in creating these activity lists, you focus on what is being done, not who is doing it or how long it's going to take or when it's going to be done. So we focus on what is being done. What exactly does activity A means, activity B means, and all of that. And this is very important because if we do not define activity, we cannot properly schedule them. Let's we go and put what is supposed to come before. Let's we go and put B before A, or C before B, or D even before A. So we need to understand what each activity is for, what it entails, so that we can properly schedule all of those activities well. So the next thing is to sequence activity. So once we've been able to define activity, then we have all the right to go ahead and schedule or to sequence them. In order of the activity, what is being done has already been defined, yes. Now the focus is to arrange the activities in the most efficient and effective ways. And then now there are a few things we consider when sequencing activity, and we are going to be talking about them shortly. And one of the things we consider when defining and scheduling activity are the dependencies. So let me quickly go through the dependencies. So the first one we have here is the mandatory dependencies. What does that mean? It simply means that so when we say few activities and they are mandatory dependency, it means that um, there's no other way to do it. We just have just one way to do it. We don't have options. So we are saying that, for example, we have to plaster this building before we can paint it. Now, I know a lot of things are happening in terms of technology around the world, but I still don't think that there's a way to paint a building effectively without plastering it first. So uh, plastering and painting are on mandatory dependencies. Plastering comes before painting, and there's really no other way to it. That is a typical example of mandatory dependencies or hard logic. The next one is discretionary dependency. Discretionary dependency says that now we have options on how to do these things. What is important is the result we get at the end of the day. So we can go by option A, B, C, D. I mean, whichever one we choose or resonate with us. But once we get the end result, we are good to go. And the third one is external dependencies. So these are constraints that are external to the project, that is to the project organization or to the body organization. These are dependencies that comes from, for example, governmental policies and all of that, climatic condition and everything like that. So the next one, which is not on this slide, is internal dependency. This is a constraint that happened within the project organization, yet it was not foreseen. So, for example, a sudden removal of a project team member could be a constraint for the project now, or to the for. Let me quickly use this extreme example. Now, a sudden death of a key project member. Now, this will be a major constraint because now this guy will not even have time to do handover documents to the next guy. If a project team member was suddenly removed from your project and put on that project, I mean, no matter how far they travel, you can still get to connect them if they want to be connected. At least you can do that online and then ask them a few things, ask them for a summary handover report or something. But then if it's a sudden death, there's really nothing you can do. You just have to pick up the pieces and figure it out. So these are the types of dependencies that we also take a look at before we sequence activities. So the next thing here is the network diagram. So for all of those things we've been talking about, from define activity to sequencing activity, eventually they are going to end up with something like this. So we are going to look at the two major types of network diagram that we have. We have the PDM and we have the ADM. So this particular example is an example of the PDM, that is the precedence diagramming method. So this is an example of the PDM, that is also known as activity on node. So each activity is represented by each box, which is also known as node. So that's where the name activity on node comes from. So this is an example of PDM, and this is an example of ADM, which is also known as activity on arrow. So instead of each activity to be represented by the circle, or in the case of PDM by the box, they're actually represented by the arrows. So that's where this name came from, the one for activity on arrow or activity on line. So that is that for this type of diagramming method. But we need to also look at this. Let's compare the PDM and the ADM. Now the ADM is old and it's no longer in use. The PDM, you don't really see them also because nobody now creates this diagram manually anymore. Nobody does that anymore. The projects we do today don't even allow some of those things anymore because they are huge, bulky, and complex. So what do we do now? PDM is now the foundation of most scheduling software to the MS Project and all of those, and even the mobile ones we have on our phones. Now, PDM is the foundation, is the principle that they all work on. Now, let's quickly compare the two. So, like I said, the names PDM, also known as activity on node, ADM, also known as activity on arrow or activity on line. And then the next thing here is to talk about their predecessor. So PDM allow for predecessor, that is finish to start. We're going to talk about that in the next slide. Start to start, finish to finish, start to finish. While ADM only allow finish to start. So you can't have the you won't be able to modify or have the options of the other three predecessors. So like I said, this is old, ADM is old and it's no longer in use, whereas PDM is the foundation for most scheduling software today. So let's talk about the predecessor. So what are the predecessors? So I said we have four. We have the finish to start, the finish to finish, the start to start, and then the start to finish. So what does finish to start means? So if we say two activities are on finish to start, it simply means that activity A has to finish before activity B can start. Simple. So activity A has to be done before activity B can begin. So that's finish to start. The next one, which is finish to finish, it shows a relationship where activity A and B can start together. So activity A and B can I mean, sorry for that. Activity A and B must finish together, regardless of when they started, when each of them started. But what is very important to us is they must finish together. The next one is start to start. So this simply means that activity A and B must start together. A and B must start together. A and B must start together. So the last one, which is start to finish, is more like the opposite of the first one, which is finish to start. So when we were talking about finish to start, we said A must finish before B can start. So talking about start to finish now, we are saying that B can start before A finishes. So we are saying that B can start before A finishes. So let's talk about lag. Lag is simply a delay. Simple, full stop. So it is different from lead or slag or float. It is just a delay, just a change of name. So when you're talking about project, instead of using the word delay, we had 5 days delay, we have 2 hours delay. It's just use lag instead. Simple. So similar as lead, this is just an accelerant. So a lead is an accelerant of an activity. You use a lead when something can begin before its predecessor is totally completed. So just like I said earlier, lead, accelerant, lag, delay. So let's quickly look at estimate activity resources. So here we just put together the resources that is needed and estimate them. So in estimate activity resources, you determine all the resources required for the project. Not just the most obvious, examine your need in terms of personnel, material, equipment, and how much of each you require. Your concern are what you need and how much of it, as well as when you need it. So that's what we do here. We look at activity resources and break them down. So these are a typical example of the resource breakdown structure. It shows what is being used per time. It shows a quick preview of the resources currently at the organization or on the project and how they are being used. How they are being used to be able to show which one is free, which one is likely to be free in the next few days or few minutes or few hours. It just shows that. So estimating method, we have 4 types of estimating method. We have the analogous, which is also known as top down. Now the advantage of analogous estimating method is it can be created quickly, that is, it is fast. Whereas the disadvantage is that it lack details and might not be accurate. So that's why it is sometimes called expert guess. The bottom up is another method of estimating. So the advantage of this is that it is detailed and accurate, but the disadvantage is it takes some time to create and it can be padded, because in bottom up you literally sum up every part of everything together to achieve what you want. So the next one is parametric. This is based on available parameters, so it can be done quickly and it's usually accurate. And this is simple because the information you will need is already with you. So for example, if you are trying to calculate how much you need to pay a consultant, you just need to know how much does this consultant charge per hour. Or if you are looking for someone to do some service for you on your project, let's say a tiler, so how much do you tile the floor per square meter? You know that already. Once you get that, you can multiply that by the square meter you need to work on, and then you have the answer you are looking for. So if you're not going to do less than that, that will be based on discount of bulk purchase or so. So the last one, which is computerized on Monte Carlo, this is accurate, can be accurate, and then what if analysis can be performed. So let's quickly look at the program evaluation review techniques, PET. So this uses three estimates per activity. So we are looking at the weighted average of the optimistic, pessimistic, and realistic. So it is just important to um, understand this formula, not necessarily master it, but just understand it so that you can always get to use them. So the optimistic plus the real plus the pessimistic plus 4 times realistic over 6, and you have what you need to calculate already. The next thing is to estimate activity duration. So in this area, the key is to estimate the number of work days or hours to complete each activity. The estimation then rolls up to create a summary of the estimate. So here we focus on how many days which will this activity take. Then we factor that out for each of the activity because we need to know how many days the whole project or the whole schedule going to take us. So after all of that done, then the next thing is to develop schedule. And under develop schedule, so develop schedule is the point where where you review resources needed. So you look at the activity sequencing, you look at activity duration estimate, develop the project schedule. So at this point, the what, that is activity list and work grade and structure, the when, the start and finish date, the who, resources, and in what order activity sequencing comes together and the schedule is born. So we need to also look at few things. Trying to complete a project without a schedule generally results in not knowing how far into the project the activity truly are. If resources are not addressed appropriately, you should focus on not knowing who should do what. If duration estimates are significantly out of alignment, the problem are associated with schedule slippage. So that is, your schedule is getting out of hand. You were planning to finish this in 3 months, and now 8 months, you don't even know when you're going to end. So that is a typical example of schedule slippage. Inaccurate activity sequencing causes work to be done in the wrong order or cause stoppage because certain activities aren't complete. Others dependent on those cannot be continued. So let's look at the critical path method. So there are a few things we need to look at. For every method diagram, we have what we call the path. So we can have up to 3, 2, 4, or as many paths as possible on the network diagram, and I'm going to show you that shortly. But then, of all the paths that we can have, there's one we call the critical path. So what makes the critical path truly critical? Now, the critical path is first the longest path on a project network diagram. I need you to know that. So the critical path has no slack but can change as the project evolves. So the question is, what is a slack? We are going to get there also. So there can be multiple critical paths. So we can have multiple critical paths if they all have the same number of days or months or years in terms of the duration of the path. So the critical path also has the greatest project risk. So the project end date can be displayed if anything on the critical path has a problem. So the project end date can be well delayed if anything, just anything has a problem on the critical path. The increase or slippage of an activity on the critical path can cause the overall finish date to slip. That is very true as well. So let's look at what is slack. So amount of time that an activity can slip or be delayed without delaying the finish date of the project or activity or published project completion date. So slack is like asking a question. How long can this activity, a network diagram is a group of, is a connection, linking of activity to activity. So activity comes before one activity, another activity comes after another activity. So how long can this particular activity be delayed for whatever reason before it start affecting No, the next activity or the total finish date of this particular project. So this can be calculated using the forward pass techniques or the backward pass techniques. If an activity has no slack, it is on the critical path, and if it slip, it will push out the finish date. So slack is also known as float. So negative and positive floats can also exist. This is a scenario in which the actual finish date extends past the targeted finish date or would be completed before the targeted finish date. So we need to understand that the float or the slack on the critical path or activities on the critical path should be 0. So where is this information going to be useful? Now you can be given a particular question asking you to calculate the slack on a particular activity. So as much as you're going to be given these different details, sometimes you just don't need to calculate anything. You just need to see if the activity is on the critical path, and if yes, just go for 0. So one of the reasons we need to understand and pay attention to some of this information is it buy you time and save you unnecessary calculation in the exam. So let's look at creating the network diagram. So everything that was discussed here, when a project starts, activity A and B can begin of that. So these are activity A and B and their duration. So we are going to use this information here to create the network diagram here. So look at this. When the project starts, activity A can begin. So this is the start box. A and B can begin. So when the project starts, A and B can begin. So what kind of predecessor is that? A and B can begin. That is start to start. A and B can start together. So the next thing is when activity A is done, activity C can begin. When A is done, C can begin. So what predecessor does that sound like? Sound like finish to start. So when A is done, C can begin. So A and C are on finish to start. So let's continue. When activity B is done, activity D can begin. When B is done, D can begin. Finish to start. Activity C and D must finish before activity E can begin. So C and D must begin before E can begin. C and D must begin before E can begin. Look at that. So what is the predecessor relationship between C and D? And what is the predecessor relationship between C and E or C and D? So C and D is obviously on finish to finish. That is, they have to finish before E can start. I hope this is clear and you are following. So C and D must finish before E can start. So activity F can begin when activity D is completed. F can begin when D is completed. You know that already. Finish to start. So activity G can begin when activity E and F are completed. G can begin, this is G, can begin when E and F are completed. What is the relationship here? Finish to finish. So G can begin when E and F are completed. So when activity G is completed, the project is complete. So when G is completed, then we enter into the finish box. So look at this. These are the duration, and then you can see it's all labeled here. So how do we now identify the parts? So part simply means if you pick it from the start button, you can go all the way to the finish button through that part. So look at this. The first part noticeable on this chart, on this network diagram, is ACEG. Yes, start to finish. Or BDFG, start to finish. Another one, BDEG, start to finish. So these are the three parts on this network diagram. The question now is, which of them is the critical part? So how do we know the critical part? Just looking at the network diagram. Like I said, the critical part is the one with the longest duration. So let's calculate the duration of all the three parts we have mentioned here. So the first one, which is ACEG, so let's calculate the duration. A is 4, C is 4, making 8. 8 plus 6, that's 14. 14 plus 5, that's 19. So let's calculate for the second part, which is BDFG. So B is 5, D is 2, which is 7, plus 1, 8, plus 5, 13. So let's calculate for the third part, which is BDEG. 5 plus 2, 7, 7 plus 6, 13, 13 plus 5, 18. So we have the first part to be 19, second part to be 13, and the third part to be 18. So which one is the longest part? The first part, which has the duration of 19 days. So ACEG is the critical part. It is really that simple. So what we said is what has been calculated here. ACEG has duration of 19, BDEG has 18, BDFG has 13. What is the critical part? ACEG, duration of 19 days. And that's it. So for every box you see on the network diagram, this is a microscopic image of it, because inside of it we have the early start, the early finish, the late start, the late finish, the activity name, the duration, and the slack or float. So all of these will not be needed. Let's just jump over them and go to the schedule compression techniques. So these happen all over the world every time on projects. So how do we make sure that we get this project done? So schedule compression techniques is the process of shortening the project schedule without modifying the scope of the project. There are two main techniques. So crashing mainly involves putting more people on the critical path item. This doesn't include rescheduling activities. So fast tracking involves analyzing the network diagram and scheduling the activity to take into consideration benefits from adjusting the sequence and all of that. So one has to do with putting resources on the project, the other has to do with modifying the network diagram. So this is an example of schedule compression. This is an example of what we are talking about. So let's compare the two, crashing and fast tracking. So crashing has to do with putting more resources on the critical path activity, whereas fast tracking has to do with doing activity in parallel that are normally in sequence. So in terms of cost, for crashing, cost usually increases. But for fast tracking, it is flexible, but there might be more costs from potential reward because it is risky. The schedules, the activities that were originally scheduled to happen one after the other, by the time you now start doing them together simultaneously, you might be risking a lot in terms of even quality standard. So let's look at the quality difference between the two. Minimal risk exposure, because you are not really tampering with the foundation and the fundamentals of this work. But when you are dealing with fast tracking, additional risk exposure because of possible rework, you are more likely to have rework from fast tracking than from crashing. So for you to be able to differentiate or remember crashing, it's as good as you are bringing more people to crash your party. More people in the party. That's what it means. So resource leveling. So what does resource leveling means? Look at this first diagram. It has on Monday 10 hours, on Tuesday 15 hours, and it has those peaks and valleys. But then diagram 2 is the same all through. So this is a typical example of resource leveling. We just level the resources allocated so that everyone now works the same hour per day, regardless of the job or the activities that is being done per time. So logic bar charts, all of this shows the interface of schedule software. It shows activity, the date, start date, finish date, duration, and all of that. So logic bar chart with dependencies, it shows dependencies, how activities are linked together. So milestone chart is typically used for executive reporting. It lacks details because really management does not want details. Just want tell us exactly what we need to hear. And if we need details, we ask. Generally listing only the main project milestone as diamond instead of Gantt chart bars. So this is a typical example of a milestone schedule. All of these are interface of scheduling softwares. So summary schedule is used to show the aggregate or roll-up view of the various activity at a summary level. So it gives senior management, the project management team, and team members a picture of how long the summary level work package are to take or and in what sequence they occur. So this is exactly what the schedule, the summary schedule looks like. So basically, that's all you need to know about project schedule. So going through it very quickly again, I'm mentioning things you need to pay attention to. So let's start from the processes. We have define activity, sequence activity, estimate activity resources, estimate activity duration, develop schedule, and control schedule. So just know what all of those activities, all of those processes means and what they are used for. The dependencies we have for mandatory, discretionary, external, internal. For predecessors, we have the start to finish. We have the start to start, finish to finish, finish to start. So we have two types of diagramming method, the PDM, the ADM, the lead and lag, the critical path, estimating methods, what is the float, understand it, creating a network diagram. So how do you tell a float? How do you calculate float? How do you quickly denote what a float is on a particular activity or on a particular part? Let me quickly show you something. So if the critical part is 19 and second part is 18, third part is 19. So what does that mean? It means that the second part that is 18 can still accommodate 1 day delay on any activity. They will still finish on day 19. That is what it means. So the float or the slack on this second part is 1 day. I hope that is clear. And then for this third one, which has a duration of 13, 19 minus 13 is 6. So they can accommodate up to 6 days delay on different activities or even on one activity. They will still finish on day 19. So that's how we just quickly calculate no float. So basically that's all you need to know about schedule management. So go through this and let me have your questions. Let me have, if you want me to go over something again, you don't understand a part of it that I mentioned, just let me know what you think. Let me know if you want me to, if you have any questions for me. Thank you for watching. See you in the next one.